Hi there, Alex, and all the rest of you good people out there. I hope that you're all safe and sound and that health is with you in these difficult times. Regarding kind of follow up on your question, where you have input, which is kind of a patterned sheet metal part or sheets. And where you have a large amount of holes, meaning a large amount of faces, and meaning a large file size. And for your downstream purpose, it seems that this is not the best combination. So you're asking for how to visually kind of show those holes without actually having them there. Normally, it's enough to for a machine, if you were to manufacture these holes, to program kind of the minimum pattern of holes that actually describes kind of the pattern, and then that will be used to pattern around the part and let that machine manufacture that pattern. But that's not the case here. You actually seems to be getting these sheet metal parts from elsewhere, and you would like to have kind of imaginary holes that are kind of rendered, but they're not really there, in the attempt to kind of minimize the file size of these parts. So I went ahead and I got to this point and describing the machine and holes and how I dealt with it in the past. And then I got kind of intrigued by a question and thought that, well, I guess I need to follow up on this to kind of make sense to it. So let's start and see what we got. I actually prepared some material here. And if we go ahead and not that one, we'll look at that one, which is the file with the imaginary holes. We can see that if I would have this sheet metal fully defined with all the holes, these holes happens to have chamfers on both sides as well, and just to kind of get to some sort of extreme size. So this is 15,000 plus holes in a sheet metal that is 1,000 by 2,000 millimeters and 1 millimeter thick. Let's open up that part and we can see that since we have quite a lot of information in this part, obviously it takes a little bit of time to handle this, and also opening, saving, etc. If we zoom in one of these corners, we can see what this sheet metal part looks like. And well, obviously you can continue working on this the way you want, but the visual effect would be if I have a object behind this. Can I make that visible as well in an imaginary hole pattern? Okay, so let's see what we can do. I believe I have an additional part prepared, which is kind of the same size sheet metal part. We can see the file size is drastically smaller. We open up the part, and this actually only have the edges defined with the holes, because on the edges it's kind of difficult to kind of render a hole. You actually need the cutout there. When it's a full hole, we can actually render it. Okay, so let's see what we can do with this. For this, I thought that we would be doing a rendering operation. I will be assigning material to this, and I will be assigning specific material to just kind of demonstrate. So here, let's see here now, in this part I have some materials prepared already. They are already in the park, so to say. And in general, I want something that would be kind of the same color as the part itself. So we're actually adding texture and color to this part already here. But these are not holes, it's just texture there. We want to actually add holes on top of that. Now, I've given away half of the idea here, which is to use one of the existing materials that would be kind of lend itself kind of nicely to this, and that is to use the base it off the tread plate visual material. Let's name this to something else so I can demonstrate where we're going. Let's name that MISC for now, miscellaneous, and let's just keep it at that. So I have prepared some stuff here because we need to create kind of a texture to create our own material. So I created this hole pattern. This is just an image. It is these holes with kind of the chamfer here. All this is actually done in PowerPoint, so you can actually do this in PowerPoint if you want to create these. So each square here is kind of 15 millimeters, meaning it's 30 across. It's 15 millimeters between the holes, both ways. They are staggered, and that's why we need this type of definition in order to create the pattern. As I said, 15 between in both directions between the holes, and the hole itself is 10 millimeters, and then we have a little chamfer there. So that would be the pattern I would be using to create my imaginary holes. So let's see if we can do that. We're going to set up our own little let's say material here, and I'm going to base it off the tread plate here because that's a good base to start with. And if I do that, we get the tread plate, and I do not have the holes, so I need to modify that tread plate that I got in there. Let's see if we can do that. Let's edit that material that I just dropped on that face there, and let's see what we can do. So under textures, we should be able to find the material used, and in this case I will actually go through all these like tabs here: base, finish, transmission, emission, and coating, to ensure that I delete all the images that this material is based on. So I just right hand click on this and I delete that image. Finish. I'm not going to use any of these finish because they're related to the tread plate here. And that should be it. So we go back to the color one, and we're going to see if we can find that image that I showed you before in that PowerPoint there. So we're going to use the whole pattern here. And we're going to be happy with that for now, I think. Thing here is we actually need to have some sort of space there. We can see they are there, but they're way too big. So the total pattern that I created before, that was actually 30 by 30 millimeters. The scale in W here doesn't really matter. So I'm going to skip that, but we can see that, yeah, it's aligning itself to the plate here. It's not aligned to the actual holes here, so we're going to have to see if we can fix that. And we can see by the holes here, this pattern actually need to change direction. Otherwise it won't fit to the definition here. So we're going to do that, and we do that by checking the texture here. Sorry, texture and space. We're going to do that by using the planar definition here. I'm going to define an origin, which I will place in this corner. I will have to adjust that later. This is just for to place it. The normal vector will be up, and the up vector is the direction of the material. So now we needed to change the direction of the holes to get the staggering right according to the holes on the edges here. I'm going to swap them around. You can see that they do fit better, but the insert point here is kind of not right yet. So we're going to adjust that, and based on the sizes that I showed you before, all this information, I can figure out that the offset here of that point, it's got to be out here somewhat and moved a little bit that way, and that is going to be 7.5 millimeters. Actually, it's going to be a negative 7.5. We start by that. It starts moving that way, and we're going to have to add a little bit to the X direction here. So we're going to have 2.5 millimeters there, so it's going to be 7.5 here. And once I hit OK, that should align itself. And there we go, we have aligned the material. Great. So here we go. Now we have created those holes. They are black. The background is white, so we're not really sure if these are holes or not. Could be, or it doesn't really have to be, but that's all up to you how you actually want that to be, because you can also add, if I take the tread plate material here that I just added, I can add a transparency to these holes here, which will kind of lend itself well to this, since this is a sheet metal part. So we go back to the texture, we see that we have a cutout here. This cutout, if I browse to my I've called it transparent, it's actually the cutout, which means that the black spots here will be cut out. And thing here is also that you need to toggle on the resize texture, otherwise it will be a really small pattern on top of a pattern. And already here we can see that, yep, we see through all these holes. So that's pretty cool. That's great. But it doesn't really stop there, because it's going to be strange if I only see the other side of that face. So we're actually going to turn it around, and we're going to drop that tread plate, the new material we created, on top of here as well. So we say drop that there, and since I adjusted the insert point and all that works quite well. And it also means that I now see through this material. Now I have chosen to, it's all up to you how you define it's your artistic view on this, on how you would like this hole to look. I kind of added this kind of shadow, and the bright spot that you get here is the visual scene here. So it's actually the light that is reflecting on here, and I need to kind of rotate it not to get that shiny. In addition, now we have kind of, you can see that they are really imaginary holes here. In addition, I kind of thought that I need to color these guys differently as well. So I will add a different texture. I will use Car Paint Solid Matte color there. But that means I need to select faces, and I need to select faces specifically that are cylindrical. And if we select all of those and we add Car Paint Matte to them, we see that we make them a little bit more fit the ones that are actually imaginary holes. The cool thing now with these imaginary holes are that they are actually transparent. So you actually, what you do is, or what you see is actually, you see right through this part. And that means that if I bring back the hidden body here, which is the red one, the one you see back here in the other part, if I bring back that red body, you will be able to see that. So you will have a material that in the rendering environment will behave as you would have holes there, although those holes, let's finish that, although those holes, if I add just regular shading, are not there. So a little bit of magic there, but could be useful for you. So we have added all these material, all these imaginary holes to the part. Let's save this part. So let's hit save. Part file saved, rather quick since the file size is not that big. And let's move over to check the file size. The sheet, let's do a refresh F5 on that, might be a little bit, no, that is the size. So the sheet metal imaginary holes, which is this guy we have here, is now 1 megabyte. So file size wise, it's a lot easier to handle, and I believe that is kind of what you're after, Alex. Now, for the pattern, as I said, easily created in PowerPoint, unless you have a great image editing software. I didn't have that available, so I used PowerPoint in this case. Works just fine. You can get some great effects here. And the whole thing here is, well, you need the dimensions here to be the same as in the NX model file for them to fit. So if I, for instance, would decrease this distance between the holes, meaning this gap here, or distance between the holes, would be smaller, that pattern would obviously not fit into the specific NX part we have here. It would be kind of a it would not fit to there simply. So the holes would be out of line in regards to the holes on the edges here. But if you have the holes inside and not touching the edges, well, then it doesn't really matter. And I think this is what you are after. So I guess with that, with these imaginary holes, I will call it a day, and I will let you go at it, and I hope that it helps in your future endeavors. So all you good people out there, take care, be safe, and above all, stay alive out there. Over and out from Fred. Bye for now.